Welcome back to the deep dive. So if you are a compliance officer, a risk manager, or really anyone tasked with navigating the absolute wildfire that is AI regulation right now,
Then you are standing at a truly critical moment, no
a
question.
truly critical moment, yeah. The rules of the road aren't just being written, they're being, codified.
Yeah,
And they're demanding a whole new professional skill set.
exactly. We've definitively passed the stage of wondering if AI is in the business. It
Yeah.
is. Now we're dealing with the messy, really essential reality of governing it.
And unmanaged AI risk isn't some theoretical problem anymore, is it?
Not at all. It's a massive threat multiplier. It can bring down a product line
Or
or
even an entire company.
an entire company.
Okay, so let's try to unpack this. I think a really foundational analogy here is that AI governance frameworks are basically the building codes of AI.
That is the perfect way to frame it.
I mean, you would never, under any circumstance, allow people to occupy a 50-story skyscraper without clear structural blueprints, right?
Mhm.
Without rigorous safety rules, fire code inspection.
A quality management system, all of it. Of course not.
Exactly. So if we apply that same common sense to these autonomous, complex AI systems, why on earth would we let them run our critical business processes, hiring, fraud detection, you name it, without those same comprehensive codes?
It's the perfect comparison because it immediately highlights the stakes. And that's really our mission today. We want to provide you, the listener, with the hard operational skills needed to master these global codes now.
So we're doing a deep dive into the three big ones.
The big three, the ones that are setting the definitive standard for what trustworthy AI actually looks like in practice. So that's the US developed NIST AI risk management framework,
Okay.
the international gold standard, which is ISO IEC 40-2001, and of course the mandatory legal force that is the EU AI Act.
All right, so before we jump into the technical blueprints of those three, we need to establish the foundation. For a risk leader, maybe someone building a governance team from the ground up, what is AI governance at its core?
At its core, AI governance is really a strategic response to all this technological complexity. It's a set of principles, standards, and practices, all designed to manage how AI is developed and used inside an organization.
So it's about reliability, trustworthiness.
Reliability, trustworthiness, and responsibility, yes. And operationally, what it does is it translates those abstract principles into concrete policies and frameworks. The goal is to minimize the potential risks, like bias, noncompliance, new security threats, privacy breaches.
All of which are being accelerated by AI.
Exactly. They're all deeply integrated and accelerated by AI across every single organizational function now.
So we all know that standard corporate compliance exists. Why are these complex AI-specific frameworks suddenly, mandatory? Why this urgent, intense focus on AI governance right now?
Because the cost of not governing AI is no longer something we can speculate about. It's a realized risk with just astronomical consequences.
It's not a hypothetical legal threat anymore?
No. The impacts are financial, they're reputational, and they carry these significant operational burdens. So AI governance, it really moves beyond those simple compliance checklists to proactively secure four crucial pillars of responsible AI that are pretty unique to machine learning systems.
Okay, let's walk through those four objectives, the things that define a resilient AI system.
Yeah.
Let's start with the one that, well, it generates the most headlines and carries the steepest social cost. Fairness.
Right. So ensuring fairness means you're implementing rigorous standards and metrics to monitor your data quality for drifts and biases. The fundamental problem is this. If you train a system using historical data that reflects past societal inequities,
Like old hiring patterns that favored one demographic.
precisely, the AI will learn and perpetuate that bias, and it's often hidden under layers of complexity so you don't even see it.
And if you deploy that flawed model,
Yeah, you guarantee biased outcomes. And that leads directly to algorithmic discrimination. So a core governance objective is mandating specific practices, like implementing diverse data collection and running continuous audits of AI systems, specifically looking for those disparate impact metrics.
okay, and the next pillar tackles what we used to call the black box problem. That's transparency and explainability. It's just hard to trust something you can't understand.
That's the challenge, yeah. A lack of transparency means deep learning models can operate as an effective black box to, well, to everyone. End users, management, and crucially to external auditors.
So a key objective of governance is to, what, pry that box open?
To provide the necessary visibility into those models, yes. And to furnish clear explainability for the decisions the AI makes. This means making the AI's processes and the data flow understandable, clear, traceable.
So stakeholders need to understand how a decision was made, not just what the decision was.
Exactly. Which is absolutely essential for forensic auditing, for identifying errors, and for, proving compliance.
Then we get into more traditional GRC territory, but I imagine amplified exponentially, protecting data privacy.
Correct. I mean, traditional compliance meant protecting data at rest. AI models, especially the generative ones, they consume and process massive, diverse volumes of data constantly. And that data frequently includes PII, personally identifiable information, in these really dynamic, complex ways.
So it's not enough to just be GDPR compliant anymore.
It's the starting point. Governing this requires stringent adherence to existing policies, GDPR, CCPA, but it also demands new technical safeguards. This means focusing intensely on data minimization, mandating secure storage, getting informed consent, and, crucially, implementing cutting-edge, privacy-preserving AI techniques.
Like what, for example?
Things like federated learning or differential privacy, which allow for analysis without ever exposing the raw, sensitive data.
Which brings us to the final sort of overarching objective, facilitating compliance.
The regulatory landscape is just moving faster than any technology boom we've ever seen. With AI regulations popping up worldwide, like the EU AI Act governance ensures that every single AI initiative adheres to legal and regulatory standards through its entire life cycle.
From idea to deployment and even decommissioning.
The whole thing, the sheer volume of data, the complexity of the models, the geopolitical regulatory fragmentation, it all necessitates a single, structured, adaptable approach to compliance across the whole enterprise.
Okay, now, let's drive home this cost of inaction with some specific cautionary tales from the sources. These aren't just hypotheticals anymore. These are real-world governance failures with measurable costs. Where should we start?
Let's start with the iTutor Group case. It's a perfect example of a bias failure turning directly into a lawsuit.
What happened there?
So iTutor Group is a remote tutoring company, and they had to pay a pretty substantial fine, $365,000, to settle an age discrimination suit from the EEOC.
And the failure was in their AI.
It was rooted in their AI-powered recruiting software. It was automatically rejecting applications based on age specifically, female applicants 55 and older, and male applicants 60 and older.
Wow.
It was a clear, unmanaged algorithmic bias. It was likely introduced because the training data just reflected age-based hiring preferences that were already illegal. The governance failure was the lack of an audit loop that could flag the use of a discriminatory proxy age, in this case, hidden in the data.
So a financial and a reputational hit caused directly by an unmanaged algorithm. And we saw a pretty big legal precedent set against Air Canada recently, right? It proved that an AI system can be treated as a legal agent of the company.
Absolutely. Air Canada was ordered to pay damages to a passenger after its virtual assistant, a generative AI tool, gave him completely incorrect information about a bereavement discount policy.
And he acted on it.
He acted on that AI-generated error. And when Air Canada tried to, shirk responsibility, the court ruled that the AI assistant was an extension of the company's communication and services.
That is a crucial case.
It is, because it illustrates the risk in these semi-autonomous systems that can hallucinate or provide inaccurate information without proper, continuous human oversight and verification processes built into the system's architecture. At the end of the day, you are liable for what your AI says and does.
And moving back to that foundational issue of hiring bias, the Amazon recruiting tool it's often cited as the ultimate cautionary tale in data selection.
It is the seminal case. Amazon developed this tool starting back in 2014 to streamline resume review, but the system was trained on historical submissions.
Which were mostly from men in the tech industry.
Exactly. So, consequently, the AI learned to automatically penalize resumes that included words common on women's resumes, like women's chess club captain. They had to abandon the tool in 2018 because the bias was just too deeply ingrained.
So the failure wasn't the AI, it was the governance.
It was the governance around the training data selection. It just underscores the vital importance of thorough, early-stage risk assessment and continuous monitoring for bias in your training data, even when that data seems historically neutral on the surface.
Okay, and finally, let's revisit a classic failure in inadequate safeguards and just deploying too fast.
Yeah.
Microsoft's Tay chatbot from 2016.
Tay, right. It was an AI-powered chatbot designed to engage with and learn from users on Twitter. Within just 24 hours of deployment, malicious users had successfully manipulated its learning algorithm by just feeding it inflammatory and offensive content.
They had to shut it down almost immediately.
Microsoft shut it down. And that incident highlighted multiple AI risk management failures all at once. Inadequate safeguards, a profound lack of content filtering in the learning loop, not enough real-time human oversight, and just a serious underestimation of the ethical and reputational risks of deploying a live, learning AI into, well, an uncurated public sphere.
So these cases, taken together, they really prove that AI risk management isn't optional or theoretical.
For a modern business, it's existential, and its failures translate directly into measurable losses.
Those cautionary tales bring us right to the solutions. So the existence of multiple global frameworks that reflects this ongoing international dialogue about how to manage AI risk, I take it.
It does. And for risk leaders today, you really can't afford to wait for one winner to emerge from that dialogue. You have to adopt a principle-based, adaptable approach right now to meet these emerging requirements.
Okay, so let's dig into the big three. We have to start with the one that carries the hardest, most immediate legal teeth and is forcing global change. The EU AI Act. What's its regulatory nature, and why should a company based in the US or Asia?
The EU AI Act is the world's first comprehensive, binding regulatory framework for AI. It was fully passed in May 2024. And crucially, it is not voluntary guidance. It has direct legal implications focused explicitly on protecting the fundamental rights, health, and safety of EU citizens.
So why does the whole world care?
Because of the Brussels effect. It's this concept that because of the sheer size and power of the EU market, any company that wants to sell a product or service there or interact with EU citizens has to comply.
So it essentially makes the EU's standards a global technical requirement.
It does. It sets a significant global impact on AI development and deployment, regardless of where the company is actually headquartered.
So the core hard skill for any compliance professional navigating this act is AI risk classification. This is explicitly required. Walk us through how the EU Act structures its categorization system.
It follows a mandatory risk-based approach, and it categorizes AI systems into 4 distinct levels. The scrutiny and the regulatory burden increase based on the system's potential impact on fundamental rights and safety.
Okay, level 1.
First, we have unacceptable risk. These are AI practices that are just deemed to pose unacceptable risks to human welfare and fundamental rights, then they are outright prohibited.
So things like social scoring by governments.
Social scoring is the clearest example. Or manipulative techniques that bypass a person's free will, like AI-driven subliminal messages. These are just clear red lines.
Complete prohibition.
Okay, what about the area where the compliance burden truly explodes? That's high risk.
That is the pivotal category, high risk. These are systems used in safety-critical areas. Think critical infrastructure, energy, transport, or healthcare, like for diagnosis or surgical robotics. Essential public services.
Law enforcement, border management.
Education, and crucially, HR and recruiting, just like we saw with iTutors. Because these systems directly impact safety and fundamental rights, they require strict adherence to a very long list of mandatory requirements.
What specifically defines that compliance burden for a high-risk system? What do you actually have to do?
Well, it mandates a formal auditable process that the compliance professional has to manage. This includes implementing a quality management system, or QMS, establishing a risk management system, creating exhaustive technical documentation, and data governance practices.
So it's a huge documentation load. Huge. Plus activity logging, ensuring you have appropriate human oversight mechanisms, and meeting really high standards of robustness and cybersecurity. The system also has to undergo a mandatory conformity assessment and be registered in an EU database before you can even deploy it.
That shifts the compliance role from just checking boxes to
integrating quality assurance directly into the development pipeline. It's a massive operational shift.
Okay, so what about the systems that fall outside of those critical areas?
The next tier down is limited risk systems. These are systems that require just minimal transparency, think general purpose chatbots or deepfake generators. They have to comply with minimal requirements, often just making sure users know they're interacting with an AI or that the content they're seeing is synthetically generated.
And then the last category.
Finally, the vast majority of systems fall into the minimal risk category. These are things like spam filters or basic inventory management tools. They're subject to minimal or even no specific requirements under the Act. They're encouraged to follow voluntary codes of conduct, but the legal hammer isn't there.
It's a very clear tiered approach, which makes the compliance duties definable at least. But let's talk about the stakes one more time. What are the penalties if an organization mishandles a high-risk system?
The stakes could not be higher. While enforcement is staggered, the penalties for noncompliance are severe. They can range up to 35 million or 7% of the company's worldwide annual turnover, whichever is higher.
7%.
That enormous financial threat immediately elevates AI compliance from a technical issue to a mandatory C-suite fiduciary concern. It demands strategic investment in governance structures.
Okay, let's pivot now to the U.S. developed framework, which is globally applicable. The NIST AI RMF, or the AI Risk Management Framework. How does this differ conceptually from the EU Act's mandatory structure?
The NIST RMF is non-regulatory, it's voluntary guidance. It was developed in the US, but it's really intended for global application. It offers a practical toolkit that's focused on managing risk across the entire AI lifecycle.
So it's less about mandating specific categories.
Right. Unlike the EU Act, it doesn't mandate a categorization system. Instead, it provides a structured, adaptable process that's designed to be flexible enough for these rapidly evolving technologies. It focuses less on legal prohibitions and more on building a responsible risk culture.
What's fascinating here is how the NIST RMF is structured. It's built around four fundamental functions: govern, map, measure, and manage. These are the process steps that risk managers need to internalize. Let's deep dive into those.
They form a continuous cyclical process, and this reflects NIST's crucial socio-technical approach, which means it involves both the technology, so the algorithms and data, and the people leadership and users affected communities.
So it starts with govern.
The first function is govern. This is the highest level. It sets the organizational tone, the strategy, and the allocation of resources for the entire program. This is the responsibility of leadership, ethics committees, and legal teams. They establish the overall risk tolerance, assign accountability, and make those high-level strategic decisions about where and how AI will be used.
So it defines the why and the who.
Exactly. Govern is the foundation.
Then we move into the identification phase.
Next is map. This is the practical process of identifying, documenting, and tracking AI risks across the system's context. This involves developers, data scientists, and risk professionals who identify the system's context, its intended benefits, its foreseeable harms, and the potential impact on anyone affected.
And the key operational challenge here is what?
Documenting everything, all the inputs and outputs of the system. You're essentially creating a comprehensive risk register that's tied to the AI lifecycle.
Okay, so once we've identified and documented the risks in the map function, we have to quantify them. That brings us to measure.
Precisely. Measure involves quantifying and analyzing those AI risks using specific metrics and testing protocols. This work falls mainly to data scientists and security teams. They conduct performance audits, bias impact assessments, and they establish continuous monitoring for things like drift in data distributions or model performance degradation.
So map is identification, measure is quantification.
That's the key difference. MAP says bias might exist here, but measure assigns a quantifiable risk score or a statistical deviation to that potential bias.
And finally, after we've quantified the problem, we need to solve it. Manage.
Manage is the action phase. This is where the rubber meets the road. This function prioritizes, mitigates, and responds to the risks you've identified and measured. It requires cross-functional response teams to establish feedback loops, which is key for continuous monitoring, and to update risk management strategies as technology and failures evolve. It's what moves the system toward a state of resilience.
I noticed the source material really emphasizes broad stakeholder involvement in the NIST RMF. It's not just a document for the IT department, is it? Who exactly needs to be at the table beyond the technical team to make this a, as you said, socio-technical success?
That is the core difference between NIST and older standards. Effective AI risk management requires a genuinely multidisciplinary approach. This means combining technical expertise with insights from legal counsel, ethics officers, HR, and social sciences, and specifically involving representatives from affected communities and the end users themselves.
Why is that so important?
Because the goal is transparency. And for bridging that gap between a technical metric and the real societal impact.
Okay, to wrap up the big three, let's talk about the ISO standard. We have ISO IS 42001. In the global compliance landscape, why is this an essential component alongside the mandatory EU Act and the voluntary NIST RMF? Where does it fit?
ISO IS 42001 is incredibly important because it provides the structure you need to demonstrate compliance with both the NIST principles and the EU AI Act mandates. It's the international standard for establishing, implementing, maintaining, and continuously improving an AI management system, or AIMS.
So if NIST is the toolkit and the EU Act is the law,
The ISO 42001 is the audited operating system you use to prove you followed the law and used the toolkit correctly.
And it provides that auditable evidence. How does it do that?
It follows the classic Plan, Do, Check, Act cycle, the PDCA cycle, which will be familiar to any compliance professional from standards like ISO 27000 for information security. It requires organizations to plan, define their context and policies, do implement the controls, check, monitor, and audit performance, and act, improve the system.
So it's a continuous improvement cycle.
Exactly. It ensures AI governance is embedded, repeatable, and most importantly, auditable. And achieving 42001 certification often serves as a powerful way to demonstrate conformity with the strict requirements of the EU AI Act, especially for those high-risk systems. It bridges that gap between abstract legal concepts and the concrete, documentable practices that both legal and technical teams need.
Okay, let's address the foundational question that I'm sure many in our audience are asking, especially those with a background in data protection. I know GDPR, and I handle CCPA compliance. Is that enough to manage my AI risk?
That is a critical question, and the answer, emphatically, is no. Compliance professionals have to recognize that data privacy and GDPR CCPA adherence, while absolutely essential, are just one component. Privacy of a much larger, multidimensional AI risk portfolio.
A portfolio that spans legal, operational, financial, and ethical dimensions.
All of them. AI trustworthiness is a constellation of critical, integrated elements that go way beyond basic privacy compliance.
So let's detail these pillars of AI trustworthiness. These are central to any modern governance roadmap. You mentioned privacy first.
Privacy is the foundation, right. It involves implementing sophisticated measures to safeguard personal and sensitive information from misuse, leakage, or unauthorized access. But this goes beyond simple data minimization. It often requires adopting advanced techniques like differential privacy.
I know that, exactly.
It adds mathematical noise to data sets. It's a way to prevent re-identification of individuals while still preserving the data's utility for training models.
Okay, so the next pillar is fairness, or bias control. We already saw the tangible cost of failure here with iTutor and Amazon.
Right. Fairness means rigorously testing and documenting your training data and the model outputs to make sure there's no disparate impact across different demographic groups. AI systems often absorb and perpetuate societal biases, which leads to discriminatory practices in lending, hiring, or even criminal justice.
And mitigation requires proactive steps.
Very proactive steps, employing diverse development teams, establishing continuous bias detection frameworks, and performing regular audits using statistical fairness metrics like demographic parity or equal opportunity difference to ensure the system gives you equitable outcomes, not just accurate ones.
Then we have explainability, or transparency, which directly tackles that black box problem. I'm curious, who specifically is the audience for this explanation in a highly technical AI system? Is it the data scientist, the end user, or the auditor?
That's an excellent question, and the answer is all three. But for the compliance officer, the primary audience is the regulator and the auditor. Explainability addresses that crucial problem where deep learning models operate as black boxes, making it hard to understand the rationale behind their decisions.
So you have to be able to provide the rationale.
You have to. This is often called explainable AI, or XAI. To satisfy compliance teams and secure audit approvals, you need technical tools like SAP values or LIME. These can provide local, understandable explanations for why a model made a specific prediction for a specific person.
And that provides the audit trail you need.
It provides the audit trail needed to justify a high-risk decision to an external body.
Okay, moving to the operational side, we need to talk about robustness. This is all about reliability and integrity under duress.
Robustness ensures the system operates reliably, accurately, and securely, even when it's under direct threat or facing unexpected data drift. This involves anticipating and defending against AI-specific threats that try to undermine the system's integrity, often through subtle data manipulation.
And this ties directly into traditional cybersecurity.
It does, because AI systems, the models, the data pipelines, the infrastructure are integral cyber assets that have to be protected.
So we need to integrate the classic CIA triad from traditional cybersecurity, but apply its principles to the AI context. Let's just briefly review those three security dimensions through the lens of AI risk.
Right. The CIA triad gives us the framework. Confidentiality means making AI models and proprietary data accessible only to authorized users. This protects against IP theft or data leakage.
Okay.
Integrity authenticity safeguards the accuracy, identity, and completeness of the asset and the processing methods. This is critical for preventing things like data poisoning or model manipulation, and availability non-repudiation ensures the AI system is available when required and that its use can't be denied, which protects critical operations like power grid management or autonomous finance systems.
So governance has to ensure the infrastructure hosting the AI covers all three of those dimensions.
Across the data, the algorithms, and the models, all of it.
Now, let's focus intensely on the AI-specific threats that risk managers must defend against. We're moving beyond traditional network attacks here, right? We're talking about threats that target the integrity of the model itself. What new vulnerabilities are defining this threat landscape?
We have to defend against three core AI-specific threats that aim to subvert the model's intelligence.
What's the first one?
The first is evasion, often done via what are called adversarial examples. This involves creating small, often imperceptible changes in the input data, a few pixels added to an image, a slight change to a sentence, that trick the model into making a wildly incorrect decision.
So it's exploiting vulnerabilities in how the algorithm makes decisions.
Exactly. A risk manager has to implement controls to detect and filter these subtle, malicious inputs.
Like changing a stop sign ever so slightly to make an autonomous vehicle think it's a speed limit sign. What about altering the system's behavior entirely and permanently?
That's poisoning. In a poisoning attack, the adversary intentionally inserts malicious data into the training datasets to modify the model's behavior in a direction they choose.
So they could inject specific biases
Or sabotage its overall accuracy, or even insert a hidden backdoor that can be exploited later. This is an integrity failure that happens upstream, at the training data stage, and it requires really stringent data governance and validation protocols to prevent.
And then finally, a significant competitive or espionage threat, model theft.
Model theft is basically the replication of the behavior of a proprietary AI model. It's often done by querying the system over and over again to infer its underlying structure and parameters.
It's a form of intellectual property disclosure.
It is. Protecting against this requires proper access control, limiting the information the model returns, and again, leveraging privacy-preserving techniques like federated learning, where the model itself never leaves the protected environment. These specific threats are why continuous monitoring and specific adversarial defense strategies are now essential controls.
We've established that AI risk is fast, it's complex, and it targets the model's core integrity. This whole environment makes traditional static risk assessment, those yearly review documents and spreadsheets we're all used to, utterly inadequate. Why do those traditional methods fundamentally fail in this new dynamic environment?
They fail because they're designed for stable, human-paced systems. AI operations happen at machine speed and scale. AI models process vast amounts of streaming data and make thousands of decisions per second. It's far beyond human capability.
So risks can propagate too quickly to be caught manually.
Exactly. A data drift event, a poisoning attack, a bias injection, they can all happen too quickly to be detected and mitigated via a periodic review. Static policies and spreadsheet reviews simply lack the resilience needed to manage continuous dynamic risk.
And this challenge is being drastically accelerated by what the sources are calling the agentic shift. This is the evolution from generative AI as just a simple tool to semi-autonomous agents that can plan, take action, and even interact with other systems.
That is the core evolution shaping the next 3 years of risk management. We're moving from a large language model that, say, summarizes a report, to an agentic AI that acts as a fully automated security operative, or conversely, as an extension of an attacker.
Which introduces new, less predictable attack surfaces.
It does, because these agents operate based on probabilistic models, and they chain their actions autonomously to achieve a goal. Their rapid deployment and self-directed nature create an acute governance challenge.
And of course, adversaries are seizing this acceleration to automate their attacks.
Absolutely. Adversaries are using AI agents to automate and streamline multiple attack steps. This ranges from highly sophisticated social engineering, think deepfake voice phishing, where criminals synthesize a CEO's voice with 99% accuracy to trick an employee into wiring funds.
Wow.
To fully automated end-to-end credential and loose and account takeovers, or ATOs. Gartner has a chilling prediction. By 2027, AI agents will reduce the time required to exploit account exposures by 50%.
50%. That shift from human-driven attack campaigns to automated campaigns demands a complete overhaul of leadership strategy.
It does. And this acceleration and complexity have, by necessity, given rise to the CISO 2.0 role. They are no longer just a technical sentinel securing the firewall. They have to be an AI-driven business risk strategist.
What does that mean in practice?
It means the CISO 2.0 has to lead security that is fundamentally built into the product and the process, not bolted on afterward. Their job expands beyond securing network edges to creating and enforcing the governance rules for how AI should operate across the entire company.
So the focus shifts to resilience, ethical use.
And demonstrating compliance to the board. They're moving from reactive risk management to being an active strategic builder of corporate integrity and trust.
Yeah.
They have to understand that AI is now the primary business enabler and the primary risk vector simultaneously.
Another major governance challenge driven by the speed and accessibility of AI tools is this dual problem of shadow AI and the no-code problem. These have to be governance nightmares because they happen outside of IT's visibility.
They are massive headaches because they bypass centralized risk controls. Shadow AI is the widespread use of unauthorized, often cloud-based, AI tools by different departments, marketing, HR, operations, without the knowledge or approval of IT or the CISO.
And this just increases vulnerability and compliance risks.
Massively. You get unknown model biases, significant compliance risks, especially with data privacy, and frameworks like the NIST RMF are crucial for bringing this usage into the light, encouraging departments to register their AI uses so risk can be managed without completely stifling innovation.
And the no-code AI problem just makes this a scale issue.
It exacerbates it, yeah. No-code and low-code AI platforms allow non-technical users to build, train, and deploy potentially thousands of algorithms quickly. This incredible volume makes it impossible for a compliance team to manually assess the trustworthiness of every single algorithm for transparency, bias, or governance pitfalls.
So you need automated auditing tools.
You have to have them. Strong, automated auditing tools and policy checks built into the governance frameworks, ensuring that every model, regardless of how it was built, adheres to the same mandated standards.
So if the threat is dynamic and autonomous, the defense must also be dynamic and autonomous. What does the solution look like for the risk manager who needs to implement a truly resilient AI governance system?
The solution is a continuous cycle of monitoring and response. First, governance programs have to mandate and track the right metrics, not just performance metrics, but integrity metrics. This establishes continuous monitoring for data distributions, model drift, or adversarial inputs, creating immediate feedback loops to address emerging issues.
You need real-time data on the health of your model's outputs.
You do. And second, to match the accelerating speed of attack, your defense must be autonomous risk remediation. This means moving away from human-paced intervention. You need strategic investment in self-healing access controls, continuous verification systems that replace periodic annual reviews, and dynamic privilege adjustment based on real-time risk scores.
Because if an adversary can have the time for exploitation, human intervention is just too slow.
Human intervention time becomes an unacceptable risk. It forces us toward automated, preemptive defense at machine speed.
We spent a lot of time discussing cost avoidance and the compliance burden.
Yeah.
But to secure budget and C-suite buy-in, executives need proof that AI governance is a strategic asset, that it generates value, not just overhead. We need to transition this from cost avoidance to measurable value creation.
That is the ultimate strategic shift for the modern risk leader. An analysis confirms that implementing a high number of trust-related actions, specifically prioritizing governance, accountability, and transparency during GenAI deployment, directly correlates with significantly higher rates of achieving expected business benefits.
So companies that prioritize trust actually do better.
They're reporting up to a 66% achievement rate on their GenAI use cases compared to those that deploy systems chaotically.
That completely refutes the common perception that stringent governance slows innovation. It suggests governance is the crucial mechanism that unlocks maximum business value safely and quickly. What about the hard financial case for this investment?
The data is compelling and immediate. 74% of executives globally report seeing positive return on investment, or ROI, on at least one GenAI use case within the first year of implementation.
The first year.
And this quick time to value is driven by agentic solutions that improve not just efficiency, but security efficacy. Therefore, the governance value proposition has to highlight this measurable efficacy over mere operational efficiency gains.
Okay, so let's focus on the key performance indicators, the KPIs for executive reporting. If I'm walking into the boardroom, what outcome-based dashboards, what numbers do I need to show?
We can break the efficacy metrics into two core areas. First, operational efficiency driven by compliance automation. For instance, using AI to automate the audit process can lead to an up to 80% time reduction in manual access review cycle time.
Which translates directly into huge operational savings.
Huge savings and faster deployment cycles. It can also lead to compliance efficiency gains, showing up to a 55% improvement in adherence rates because the checks are integrated digitally, not manually.
And the second area.
Second, and most critical for the CISO, is risk reduction efficacy. This is measured by the reduction in mean time to detect, MTTD, and mean time to respond, MTTR. For example, global financial institutions are achieving fraud detection within 50 milliseconds using AI-driven systems like MasterCard's Decision Intelligence.
50 milliseconds.
And separately, a major retail bank saw a 65% reduction in account takeover incidents by deploying AI systems for continuous risk scoring. The key takeaway is that strategic AI governance ensures the AI you deploy for security dramatically improves the quality of defense, not just the speed of tasks.
That really confirms how governing AI transforms security from a necessary cost center into a measurable value driver. Now let's look at advanced AI use cases where organizations are using AI within risk management to solve previously impossible problems, especially around regulatory hurdles.
One of the most strategic is federated learning. Traditionally, privacy laws and competitive pressures have prevented institutions, say multiple banks, from pooling sensitive transaction data to detect large-scale cross-institutional fraud or AML threats.
Because sharing raw customer data is a regulatory impossibility.
It is. Federated learning solves this profound compliance challenge by adopting a decentralized architecture. Each institution trains local AI models on its own private, proprietary customer data. Then, only encrypted model updates, the mathematical learnings, not the raw data, are securely shared for secure global aggregation.
And this achieves really high accuracy without sharing the data.
Extremely high accuracy, often measured with an AUC area under the curve greater than NARGL 0.95. For a risk manager, an AUC over 0.95 means the model is nearly perfect in distinguishing true positives, so real fraud, from false positives, innocent transactions.
A level of efficacy you could never achieve manually.
Or without pooling intelligence. And you do it all while maintaining perfect customer data privacy and regulatory standing.
That is a remarkable way to achieve collective intelligence while navigating those strict regulations. What about the issue of stress testing for extremely rare, high-impact events, those crucial tail risks?
That's where generative AI for synthetic risk scenarios comes in as a game changer. High-impact, low-frequency events like market flash crashes, sudden geopolitical events, or massive coordinated cyber attacks are inherently rare.
Which means traditional risk models fail to cover them because there's so little historical data.
Exactly. So generative AI powers the creation of hyper-realistic simulated risk events. By creating thousands of these synthetic risk scenarios, organizations can rigorously stress test the tail risks that their historical data alone could never predict. This drastically improves the resilience required under the NIST and ISO frameworks.
We've covered extensive ground today. From the high costs of governance failure illustrated by those specific court cases to the technical operationalization required by the Big Three frameworks. The core conclusion we have to internalize is that AI governance frameworks are not roadblocks that slow innovation.
Not at all.
They are the strategic mechanisms that unlock maximum business value safely and ensure regulatory success in this dynamic, high-speed environment.
Absolutely. The foundational takeaway for every risk professional is the necessity of adopting a truly multidisciplinary approach. Effective governance requires mandatory collaboration, combining technical expertise from data scientists and developers with the crucial insights from legal, ethics, and social sciences. This necessary transition demands significant strategic upskilling within the organization.
Okay, let's leave our listener, the risk manager or compliance officer, with a final provocative thought focusing on their future talent strategy and professional development. Where should they focus their energy to become indispensable in this field?
Well, the industry faces acute talent shortages and risk and compliance experts who can genuinely bridge that gap between policy and technology. To successfully implement these frameworks and achieve the regulatory success we've discussed, you need to become a certified risk translator.
A risk translator, what does that mean?
It's someone who can articulate the legal mandate from the EU Act into a data scientist's requirement for specific model card documentation. or who can translate a technical failure in the NIST map function into an actionable management policy.
So strategic upskilling is necessary.
It is, particularly in certifications focused on operationalizing governance. Things like the NIST AI RMF Architect certification or the IAPP AIGP, which is the AI Governance Professional. These programs are crucial for translating abstract concepts into standardized, actionable enterprise policies that lead to verifiable compliance and ultimately to regulatory success.
So the journey doesn't end with training and policy writing. It requires continuous adversarial vigilance.
Precisely. You have to commit budget and resources to continuous testing and assurance. For instance, LLM red teaming simulating adversarial attacks like prompt injection, jailbreaking, and data poisoning is now necessary to detect vulnerabilities and provide real-time assurance against threats.
To ensure your AI systems remain secure, ethical, and robust throughout their entire life cycle.
That's right. And that commitment to continuous testing is the ultimate measurable benchmark of organizational trust. That is the next step for every organization operating AI today.